Let's go ahead now and do the assembly of the circuit. So what I'm going to do next is I'm going to assemble the circuit that I've got here in the demonstration schematic. There's quite a few components that are involved. I've got my 8 resistors. Each one is a 220 ohm current limiting resistor. Here's my 595 shift register. I've got my 8 LEDs here and lots of jumper wires. I'm going to put the circuit on this mini breadboard here. I'm going to fast forward the assembly since it does take a lot of time, but when the time comes for you to do the same and repeat it, be very, very careful because it is very easy to make a mistake. I'm also going to be using this battery to test the polarity of my LEDs because these LEDs that I've got here have pins of the same length, so I can't readily figure out which one is the anode or the cathode, and I also find it quite hard to have a look inside the package here and try to figure out which is the anode and the cathode that way. So I'm just going to simply use the battery and flip it around, and now I know that this pin here is the anode because when I connected it to the plus side of the battery, the LED lit. So that's how I know which one is the anode and which one is the cathode. I'll be using this battery a lot. Okay, here we go. I'm going to start with the 7-segment display and just plug it, say, around here. And notice that the dimple here is towards the outside, the left side of the 7-segment display. Then I'm going to use my orange wires first to drive the LEDs. So here's the first one. So this first orange wire is QB. Eventually it's going to drive one of the LEDs. And I'm going to do the same for the rest, one at a time. Okay, at this point I'm also going to connect ground, which is right on at the end, pin number 8 at the end of the one side of the pins. I'm going to connect ground because I'm going to do another layer of orange jumper wires, and then it's going to be pretty hard to find the socket here at this location. So let's go for ground next. So that's ground. And I'm going to use another 3 orange jumper wires for the rest of the bits on the bit outputs, I mean on this side. Just 1, 2, and 3. Just well packed. Next, I'm going to do QA. The wiring for QA, and because I want all my LEDs to be around in the same area on the breadboard, I'm going to use a green jumper wire and bend it around and connect pin 15 on the 595 chip, and I'll connect it, say, here, right on the next row of pins after the last orange jumper wire. So with that done, I can now start connecting the LEDs. So always making sure that the polarity is correct. So you can see here, according to the schematic, I'm going to connect the anode of each LED to the 5 volts on the Arduino, or the 5-volt rail on the breadboard. So I want to make sure that the anode of each one of the pins is pointing upwards, and eventually through a resistor I'll connect it to the red power rail. Okay, so here's a battery. Let's try to figure this out. So this is on. That means that this pin here should point upwards. There's one. Next. That's on. So plug that next to the first LED. Nope, turn around, yep. So that side goes upwards. Next, yep, so that side is correct. That orientation. Yep. That way. 3 left to do, so nope, go flip it over. Yes, so that goes up. 2 left. No, flip it over. Yes. Okay, and 1 more. Great. Alright, so far so good. Just try to align the LEDs. So get 2 rows of 4 LEDs each, because they're really close to each other. So this is what my circuit looks like now. So the next thing to do is to add the resistors on the anode of each LED. So let's zoom in a bit. Okay, here's the first resistor. Second. Third. Fourth. Fifth. Number 6. Number 7. And last one, number 8. Okay, there we go. So just double checking that every LED on its anode has a current limiting resistor. So that's fine, good. Yes, and they're all good. I will go to the red, the positive power rail. The next thing to do, as looking at the schematic, is to connect the data, clock, and latch wires to the Arduino. We need to ground pin 13 and to raise to 5 volts pin number 10. So I remind you that pin 13 is the enable pin, and pin 10, this one here, is the clear inverted pin. We're not going to be clearing or enabling. We're going to keep the shift register to always be enabled. So we're going to bring that up to 5 volts. So let's grab one of these. So that's 1, 2, 3, 4. That will go to ground. I should get a grey one. Needs to be a little bit longer. Okay, so that's pin 1, 2, 3, 4 on the right side. So this is the enable. This is pin 13. This one here. And next we're going to do pin 10, which we need to raise to 5 volts. So pin 10 is this pin right here. It's a clear inverted. So it's the second on this side, second from the right side as you're looking at the shift register in this orientation. So it's this one here. Okay, that's done. I am also going to use a white pin to provide power to the chip. So I need to connect pin 16 VCC to the positive rail. So that goes there, like that. Next is that I need to connect the 2 negative and positive rails together on either side of the breadboard. So I'm going to use 2 jumper wires for that. And the positive. And the last thing to do is to connect the Arduino now to the circuit. So first let's go for the data pin. So that is pin 14. So pin 14 is this one here. So it's the third from the top where the dimple is. So it's this one here. And that goes, looking at the schematic, and that goes to pin number 8. Okay. Next, we've got the clock pin and the latch. So I'm going to use a double jumper wire for that. These are the 2 pins here So clock is pin 11 on the shift register, and latch is 12. So this one is 11 and this one is 12, the clock. So clock needs to go to pin number 10 on the Arduino. So the blue wire will go to number 10 and the green wire will go to pin number 9. And that concludes the construction of this circuit. So let's move on to the sketch now and see it in action. Thanks for watching. If you'd like to learn more, check out my Arduino Step-by-Step Getting Started and Arduino Step-by-Step Getting Serious courses on the Tech Explorations School. There, I help you develop basic and more advanced Arduino skills, including how to write your own programs, how to use all sorts of sensors and actuators, and how to create your own gadgets. You may also be interested in my project courses, where you get deep into the development of wheeled robots, remote-controlled cars, and drones. Please use the coupon code in the description below this video to get a YouTube exclusive discount to my courses. See you there.